This animation addresses 5 common variations of P-type seismic body waves. All are compressive waves that travel through the mantle in all directions away from the epicenter of an earthquake. The additional letters refer to travel in the mantle and outer and inner core. P-waves travel a simple curved path through Earth's mantle, refracting along layers at depth and return to the surface at about the angle that they left the epicenter. P-waves arrive at seismograph stations up to 103 degrees from the epicenter. Seismometers farther than that will record changes from other waves as the wave encounters the crust and boundaries between the mantle, outer, and inner core. The first variation of the P-wave we address is the PP wave that travels only through the mantle, but the PP wave is bounced once off the Earth's surface between the epicenter and the recording seismometer. PP waves can be seen at recording seismometers any distance from the epicenter. Again, it is a simple P wave that is reflected off the surface of the Earth at the angle that it arrived. PKP describes the path of the P wave that refracts across the mantle outer core boundary. It travels more slowly through the liquid outer core than through the solid mantle. It speeds up again and continues to travel through the mantle to the seismic station. PKP waves can be recorded at seismometers farther than 140 degrees from the epicenter of the earthquake. This is due to the velocity contrast between the mantle and outer core, with refraction controlling the possible angles the ray will take as it travels through the Earth. A steep initial ray path will result in a ray that will travel through the inner core. The PKIKP seismic ray travels in the mantle until it intersects the mantle outer core boundary. Seismic energy is refracted across that boundary, slows in a liquid, and aims at the solid inner core, where it speeds up again, then refracts and slows down again through the outer core before its last leg to the mantle. Aside from the PP wave, that is not a direct wave, but a reflection of the P wave, there are no arrivals of the direct P waves between 103 degrees, where the direct P waves end, and 140 degrees, where the PKP wave shows up, creating what is referred to as the P wave shadow zone after 104 degrees. In addition, the amplitudes decay dramatically beyond 100 degrees. However, compressional energy can arrive at seismometers in the P wave shadow zone. If the advancing P wave strikes the core mantle boundary at the proper angle, it will travel along the base of the mantle, sending compressive energy back to the surface to seismometers within the shadow zone. These ray paths and the corresponding arrivals to seismometers within this region are labeled P-diff. On seismograms, P-diff waves usually have small amplitudes and gradual onsets. This is due to the loss of energy as the waves are diffracted by the core mantle boundary. The intricacy of P-wave refractions and reflections permits us to learn incredible things about the dimensions and properties of the deep Earth that would be impossible without sophisticated analysis of these complexities.